Okay, the third step in the instructional design process has to do with context. Such an important part of the instructional design process, and in my opinion, it is the most exciting, interesting, creative, and fun part of the experience, no question about it. This is the part where you've identified an instructional goal. You're pretty clear about what you want students to be able to learn how to do forever. But then you have to say, okay, well, how am I going to get them to be able to learn this in an environment in which learning it has meaning and purpose and is real? And hopefully the context will provide inherent opportunities to explain, interpret, apply, shift their perspective, emphasize, self-assess. All of those things will be inherent in the learning context, because and the reason why this is so important and so exciting is that if you think about all of the things that you have learned how to do well in your life, really learn how to do well, there's a very good chance that the reason why you were able to do that is because learning how to do that was mired in meaning and purpose. And there was a reason for everything you learned how to do. You learned how to speak, listen and speak and interpret language before you knew how to write it, before you knew how to read it. You learned all of that at a very early age with minimal PowerPoints, minimal lectures, minimal online interaction. You learned it because the strategies were embedded within a context that was very real and very purposeful to you. And that is so important to consider. Okay, now in this particular class, one of the things that I do in the notes is present a real basic model of contexts that do provide meaning and purpose to learning lots of different things. And these contexts, the way they're described and arranged, again, are the result of an analysis of lots of different kinds of constructivist-oriented design models and evaluations. And so I have these three main areas: creation, problem solving, and real/simulation. Those are like primary context areas. And then there are some sub areas that, again, are very common in the literature about contextualized learning environments. And I put them in a Venn diagram like the one presented because there's a lot of overlap for some. For example, if you look at creation, well, storytelling is a wonderful act of creation. It doesn't necessarily fit into the real category or the problem solving, but it is definitely an act of creation that can be very, very effective for people. Now, concept mapping is also an important act of creation, and a very cool and interesting one. But that's when you start to get into creation that begins to focus on solving problems, because usually a concept map, like you had to do in this project, try to identify what the concepts were and the relationship between concepts and subconcepts and all of that. Creating a concept map. That's an act of problem solving on your part, and so it would fit into both of those categories. So I want you to focus on these, and I was my encouragement for the different design classes was to look at this model and to hopefully generate some kind of inspiration that would emerge for the particular project at hand. I have to say a special note, a special shout out to a group that did identify a context for learning the skills identified in this particular design project, and did it in a very, very good way. This would be to me a problem solving / simulation kind of way that they did it. This one group decided that if the students were going to have to learn how to identify differences between plant and animal cells using observations. So again, they're getting science process skills in there, and they're also getting content skills in there. But they said, so why would anybody ever need to learn how to do that? What's the context for it? Well, the reality is when you analyze water, particularly water from wells, it's important to ensure that the water quality is safe. And one of the things that is done in the real world is that water samples are analyzed for the presence of certain chemicals, yes, but also living things as well. Those, by the way, can prove to be very problematic for humans. And so, and elaborating further, knowing the difference between something like an algae, which is a plant cell, microscopically, and an amoeba, which could be considered an animal cell. It's a protist, but it still possesses the characteristics of an animal cell. Observing those two living organisms in a water sample, being able to differentiate between those two is super important. If you have amoeba in your water, that's something that, in general, you probably don't want to ingest without some treatment. Whereas algae may or may not be anything that you need to worry so much about. I suppose it depends on the type. But what a great context. So they're going to develop a learning experience in which students are immersed in a problem-solving environment where testing water samples is part of the environment. And in the process of doing that for a purpose, then they're going to have to learn and apply all of the other skills associated with, identifying microscopic things, knowing the difference between a cell and something that's not part of a living thing or not a living thing. Anyway, fabulous, great idea. And again, it drives the rest of the design process quite a bit. And I was very happy to have that kind of thinking going on in this class.